pwede pa sila mag-final four.
Possible na matalo na nila yung Adamson UE.
Kaya.
Pero pag yung FPU natalo nila,
Okay, so the discussion is on reliability. Wherein we understand reliability as consistency in measurement. Okay, so when we talk about reliability coefficient, so this is the statistic that allows us to quantify reliability, and this ranges from 0 to the tool being not reliable at all, to 1 as being reliable, perfectly reliable. So you can think of correlation statistics in relation to this one. Wherein pag sumobra sa 1.0 yung computation mo, definitely there's something wrong with your computation. So remember that one, kasi nga there are instances na nagko-compute or ang binibigay or ang nare-report na number is not reliability coefficient but other numbers na nilalabas doon sa statistical program. So again, wala tayong reliability coefficient na that would be more than 1.0. Yun lang. 0 to 1.0 ang range ng ating reliability coefficient. Now, talking about this one, this is a very important formula to remember when it comes to reliability. So wherein we have the observed score is equals to true score plus the error. So wherein when we talk about error, again, it is not limited doon sa mistakes na mga yung answer na would be marked as wrong sa test, like for example sa quiz natin. So it's not like that. It's all the variances that are that affects the observed score as well. So to simplify it, we can put it in this formula, which is x plus t plus e, x rather, is equals to t plus e. So x being the observed score, t being the true score, and e being the error. However, again, this is something that will be difficult to measure because of the fact that in terms of getting the true score, it's quite difficult to get the true score. Wala pa ako ever na nakita nakakuha ng true score nila because this is a score that is present in a very ideal assessment process. So we go for this type of formula instead, wherein the best way to measure all these variables is to look for its variances, wherein we have the variance is equals to true variance plus the error variance. So again, if you would see this formula, it's quite similar to this formula. We just made it into variance for this to be more mathematically possible. So when we talk about, again, reliability, in this context, we're seeing the proportion of the total variance that is attributed to the true variance. Okay, so ma'am, sabi mo kanina hindi ma-measure yung true score. So, in terms of that, medyo kumbaga, difficult din ba ma-measure ang true variance? Not so, kasi in the equation naman, makukuha natin tong observed score and makukuha din natin yung variance nung error. So, getting these two will allow us to somehow arrive to the true variance, which is ang ating which is the variance of the true score itself. Now, in relation to that ulit, ayan, kailangan nating hanapin ang measurement error. So when we talk about measurement error, this is the inherent uncertainty that is associated with any measurement, even after care has been taken to minimize preventable mistake. So, as test developers, one of your aims is to ensure that it's reliable. Your test is reliable in the sense that you are ayan, kaya nga kayo nagpapa-validate ngayon ng mga item bank nyo, item pool nyo in order to see kung talagang yung mga items, yung mga pinagagawa nyo doon sa construct nyo is really related doon sa construct nyo, as well as doon sa mga domains na ginawa nyo within the construct. Aside from that, you're also trying to develop now the particular instructions that you will be giving to the test takers in the future. So, pero, kahit na ginagawa nyo na yun, yung mga steps na yun to minimize the measurement error, again, it's something that cannot be avoided. It's there kahit anong careful natin sa mga measurement na to. It's there kahit na anong try natin gawin yung standard or the ideal testing administration. Okay. So, makikita natin yon sa dalawang types ng measurement error. So, we have the random error and the systematic error. So, the random error, actually between the two, this one is the one that's easier to control. Ito yung mas mabilis nating makita, and of course dahil nakikita nga natin siya, mas mabilis natin siyang ma-address, unlike the systematic error. Kasi with systematic error, this is the one that is presumed to be the true value of the variable being measured. This one would be difficult to identify, and so we just try to address the random error in place of this one, kasi ito yung medyo tricky talaga. Okay, now when we talk about random error, we're talking about fluctuations and inconsistencies of other variables in measurement. So, for example, is noise. Pero talking about it further, these are some sources of error variance that we have. Okay, so una-una dyan is your test construction. So, the test construction, ayan, baka may mali sa item sampling mo, kaya again, item validate kayo sa mga subject matter expert, diba? Yun yung sabi ko sa inyo. Hindi porket may lisensya, agad-agad na subject matter expert siya. So, there are some people in your batch na kailangan nila ng subject matter expert na beyond psychology. Like, for example, may gumawa ng construct about nationalism. So, they need a subject matter expert that can give us really an idea, or para magsasabi talaga sa kanila na, oh, tama or mali yung definition, or yung or hindi nakaka-capture ng mga items yung definition nyo ng nationalism dito sa construct na to, or sa test na ginagawa nyo. So, ayan. So, by doing or by asking the subject matter experts to validate the items inside the test, we're already trying to address the sources of error variance. Another source of error variance is the test administration. So, the testing environment can be a good place kung saan maraming error variance. So, unang-una na doon, of course, are the test taker themselves, diba? Kaya nga sabi ko nga sa inyo, when you have major exams, you have to be at your optimal best, kasi it's your responsibility to make sure that you will be able to get the best possible score. Kasi nga, again, the best possible score is the one that's nearer to the true score. Okay, on the other hand, ayan, pwede rin maging source of error variance yung examiner. So, kami rin mga nagpapatest. Pwede yon. So, unang-una, ayun, kung mukhang hindi siya proctor, ayan, problema yon kasi how can you trust them to administer the test well if they don't look the part? Okay? And then, of course, the demeanor will also be playing a role. Like, for example, pag departmental exam nyo, tapos mas maingay pa yung test administrator, di ba? So, kumbaga, siya mismo yung nakaka-affect doon sa focus ng test taker. Diba yung kumari, tahimik, tapos nagtitest kayo, tapos biglang magkukonto yung proctor na, ay, alam nyo ba, ganito. Parang, bakit ganon? Kasi, the test administrator themselves is causing the error variance. So, if that happens, call them out. Kasi that's something that shouldn't be done. Makikita nyo rin yan sa mga exam, sa pag nag-board exam na kayo o kaya pag nag-civil service exam kayo, the test proctor barely speaks. Hindi yan dapat magsasalita. Magsalita man yan, they will only talk about the instructions. They will only ask if there are any questions after they explain the instructions, and they will also only talk pag time check. Yan. Kasi nga, again, the reason why they are quiet, it's because they should not be a source of error variance, because the goal here is to get the test taker to the nearest possible score that will reflect their true score. Okay. Now, aside from this one, another source of error variance will be the test scoring and interpretation itself. So, the test scoring and interpretation, actually na-address na yan with the use of computer testing. Kasi nga, the program itself does the administration of the tests as well as scoring of the tests, and it reduces the error in scoring. However, there are still tests that will require the expert interpretation. So, a good example for this one is MMPI-2. So, MMPI-2, it can be scored by the computers or the program for MMPI-2. However, in terms of interpreting the numbers that will be yielded from the computer scoring, ayan, expert interpretation na ang kailangan doon. Kaya nga MMPI-2 is level C test. So, kahit walang problem yung scoring, if the test user is unable to interpret these numbers, then totally walang kwenta yung test nyo. Okay. Now, if you would ask, ma'am, paano po dito sa Pilipinas? Again, the practice of psychology here in the Philippines is quite young. So, even in assessment, medyo behind pa rin tayo. Kaya, most of the tests that we're using are done manually. It's just a bit sad that there's a lack of support in investing in these assessment tools. So, especially in the government agencies, but in companies or industries, private industries, ones such as shipping, they are willing to invest on this. Kasi nga, they know that this will help them in having a pool of employees that will make the make the job perfect or complete. Okay, so aside from this one, ayan, we can also see sources of error variance ito sa mga election to, surveys and polls. So, although they would contain a disclaimer ng margin of error associated to their findings, as they should, because it's part of their ethical practice, we do know that this do not happen with campaign surveys and poll, di ba? Kasi may minsan, lalo na nung last election, may mga sinasabi sila na siyam sa 10 Pilipino ay boto kay ganto-gantong kandidato. And then if you would think about it, that's 90% if ganun kadami yung sinasabi nila na 9 out of 10. Ang tanong doon, asan ka doon? Bakit parang wala yatang nagtanong sa'yo? Kung 90%, hindi ka man lang na-randomize na napili doon sa poll na yon. Kaya, it's a bit misleading yung ginagawa nila. Kasi nga, the margin of error is not really specifically stated in those kinds of advertisement. Dapat in-explain nila yun eh. Okay. Another is the sampling error. So, this is, the extent to which the population of voters in the study was representative of the voters in the election. So, ito yung napapansin yung tinatanong ko kayo while you were asking for my signature doon sa mga papers na ipapasa nyo sa ethics committee. Kasi we're trying to avoid the sampling error. Bakit? Kasi nga yung iba sa inyo, you're already assuming something when the tool has not yet been completed. So, like for example, yung may isang grupo nga na ang gusto nila ay yung leadership. So, ang sampling nila ay student leader lang. Sabi ko, bakit student leader lang? Kasi parang you're working under the assumption na sila lang ang may leadership skills. But again, we're working on the assumption ni Allport na lahat tayo ay may certain traits to a certain degree. So, if that's the case, kailangan natin ng general sample, regardless if they are a student leader or not. Otherwise, when the tool is already developed, how would you know that this student leader has has a good leadership skills or high leadership skills kung hindi mo nga na-establish what is the low, average, and high leadership skills sa general sample or from the normative sample themselves. If you want to have a leadership skills na pang or leadership level of leadership skills na pang student leader lang, then that's the time that you are going to have a specific norm only to themselves para makita natin yung difference between the general sample or the general population or sample from the population and the sample of this specific group of people. Okay, another is the methodological error. So, this is the result of interviewers who have not been trained properly, ambiguous wording in the questionnaire, or the presence of bias in the questionnaire. So, the method itself can be a source of error. Kaya nga, again, we're very careful, or the APA have specifically given levels of levels dun sa mga tests natin. Kasi nga, hindi po pwedeng kung sino-sino lang ang mag-administer nun, kasi if the person had been not trained properly in the use of that test, then that's going to be part of the error. So, mas dadami or mas tataas yung measurement ng error niya, and this will make them deviate further from from getting a score that is nearer to their true score. So, what's a good example? A good example would be, ayun nga, yung kwento ko sa inyo last time, wherein I have the clerk from the clinic to help me out in giving the test doon sa mga magnu-neuro exam for DepEd Mindoro. So, since he was not trained properly in group testing as well as the administration of that particular test, which is at that time, I believe it was an IQ test, he was already showing bias towards one particular tester just because natipuhan niya, diba? So, that is already problematic. So, anong mangyayari nun? Mangyayari nun, of course, the error variance, tataas yun. Tapos, yung magiging score niya ay mas malayo doon sa, the observed score will be further from the true score. Also, the words inside the questionnaire themselves are going to be part of the problem. So, sa MMPI, meron tayong isang item doon. I have loved with ED my father before. So, parang, ano daw? So, pag true ang sinagot mo, parang, so, hindi mo na mahal yung tatay mo ngayon. Parang ganon. Pag false naman ang sinagot mo, parang ganon din ang ang ending ng sagot mo. So, it's quite difficult to understand that statement kasi regardless kung true or false yung isasagot mo, parang same din siya ng magiging result. Also, the presence of bias in the questionnaire. So, mga bias question, again, the subject matter experts are there to scrutinize thoroughly your pool of items to see kung may bias ba doon or wala. Okay, now moving on to the reliability estimate. So, marami kayong pwedeng pagpilian dito. Although some of these reliability estimates are not being used anymore, but depending on the type of reliability estimate that you want to establish, ayan, intindihin natin kung ano yung mga reliability estimates na yan. So, the first type, of course, is the test-retest reliability. So, when we have the test-retest reliability, automatic na yun na you're trying to establish the reliability of a test by comparing or correlating the scores of the same people on two different administrations of the same test. So, like for example, I want to establish the reliability of Beta 4. So, Beta 4, kumare. So, bibigyan ko kayo ng Beta 4 ng first sem, and then after some time, same people, kayo ulit yon, Beta 4 second sem. So, that's test-retest reliability. So, pag nakita ko na mataas yung correlation ng scores nyo doon, ibig sabihin, this particular test is quite reliable. Kasi nga, after a period of time ang nagpapas dito. Okay. So, this is the type of reliability estimate that we use for variables that are stable over time. So, this is a good reliability estimate to use when you're testing the reliability of a test that measures personality trait, and it's not appropriate for variables that are expected to change over time. Ano ibig sabihin nun? Ibig sabihin nun, if you're trying to test out a tool that measures anxiety, paano kung within that period of time, let's say 6 months, nag-therapy na siya. So, definitely, it's not a good fit for this type of test. Ma'am, sabi mo kanina, personality trait. Yes, personality trait, but personality traits that are stable. Okay. So, with reliability or test-retest reliability, we can see that the correlation between scores tend to decrease as time passes. So, ayan, the longer the time, the lower the correlation. Bakit? Kasi nga, the time is an element to this type of reliability. Kaya nga, ang tawag natin dito sa intervals ng test-retest reliability, which is more than 6 months, is coefficient of stability na. So, nagiging coefficient of stability na ang tawag natin dyan. Okay. So, hopefully you're still with me and you're still digesting the things that I have said. Madugo lang to. Don't worry, pagdating ng validity, mas madugo pa ang discussion natin sa validity. Okay. So, moving on. Aside from coefficient of stability, we're also establishing coefficient of equivalence. So this is another reliability estimates, and this is the one that measures the degree of relationship in different types of tests by means of either an alternate form test or a parallel form of test. So, what's the difference between the two? So, pag parallel form, the means and the variances observed from the test scores are equal. So, that's a parallel form of test. The alternate form is, this is designed to be equivalent with respect to variables such as the content and level of difficulty. So, may mga test tayo na may form L, form B, yung mga ganyan. Like, for example, yung MAB2 nyo, may form something siya, form ganon. So, alin doon, or can you say that, or how will you identify MAB2? Kasi nga may dalawa siyang forms, right? Is it a parallel form or an alternate form? Sige, tingnan yung mabuti. Since na encounter nyo na at nakapag-test na kayo ng MAB2. Based on the description, ano siya? Identify nyo kung anong type ng form siya. Is it an alternate form or is it a parallel form? Okay. Now, when we obtain the estimate of the two, regardless if it's alternate form reliability or parallel form reliability, this is just similar with the or how we compute the test-retest reliability. So, and also, ang kaibahan niya lang, kung si test-retest reliability is where administering the same test to the same group of people over an n period of time, si parallel and alternate forms, ayan, you have to administer the two forms of the test to the same group. So, walang element of time here. So, kailangan mo lang i-administer yung dalawang form ng test sa kanila. Okay. Yun nga lang, this particular reliability estimate can be affected with error related to, ayan, practice effect, and of course, fatigue, as well as item sampling. Kasi, totally may mga forms kasi na syempre, kumari, nasanay ka na dun sa naunang form, tapos biglang in-expect mo, ganun din yung other form ng test, tapos biglang hindi pala. So, may ganung factor din siya. Okay. Now, the other one is the split half reliability. So, the split half reliability actually is the OG reliability estimate. So, if you know Anastasi, si Anastasi yung unang libro na mga binabasa ng mga psych major for psychometrics. Ito yung pinaka number 1 yung dinidiscuss in terms of establishing the reliability estimate. So, how do we do the split half reliability? So, we do the split half reliability by correlating two pairs of scores obtained from the equivalent halves of a single test administered once. So, pwede kasi siyang ganito. I-divide mo, kumari, 40 siya. So, yung 1 to 20, that's group 1, and then 21 to 40 na test takers or test protocol. So, that's group 2. And then, you're going to compare the scores of group 1 and group 2 using Pearson R to establish the split half reliability. But after getting the R or the Pearson R from this particular data, you have to adjust the half-test reliability by using the Spearman-Brown formula. So, ayun naman yung gagawin mo. Okay, now the Spearman-Brown, medyo tedious lang siya kasi after Pearson, you have to use Spearman-Brown pa. Ayan. Mas nakukuha niya yung better estimate ng internal consistency, reliability from the correlation of these two halves of the test. So, yun yung ginagawa ni split half. So, actually, mas maraming gumagamit nito since it's quite easier to do kasi you're not going to administer two tests. You're not going to administer the same test over after a period of time, 'di ba? Yung test retest. Ang gagawin mo lang is i-divide mo lang yung group into equivalent halves. Ano yung score ni group 1 and group 2, and then you calculate the correlation of the scores between the two to establish this reliability estimate. However, since may mga mas advanced formula na tayo to really get to better number of reliability estimate, hindi na masyado ginagamit tong split half reliability in psychometrics. I think more on sa education na lang siya mas na-utilize. Okay, so other methods of estimating the internal consistency, inter-item consistency, which is the degree of correlation among all items on the scale. So you're going to be using this. We will be using Jamovi, of course, and also use JASP to see or for us to establish this particular reliability estimate. Ito yung mas kailangan natin. Kailangan natin makita ano yung correlation ng item 1 against all items on that particular scale. Okay. Then the other one is coefficient alpha, although now we're using or in your case, in your project, we will be using McDonald's omega. We're not going to be using alpha anymore. Secondary na lang siya dun sa omega. Anyway, but to discuss to you what's coefficient alpha. Coefficient alpha is the mean of all possible split half correlations. So, kaya ito yung ginagamit before kasi nga, it's split half reliability, just better. Yun lang siya. Okay, but again, from the literature, ang mas ginagamit na natin sa psychometrics is the McDonald's omega rather, McDonald's omega, not alpha, because of the fact that it's more robust, meaning to say, mas nakukuha niya yung a specific estimate nung inter-item consistency unlike with alpha. Okay. So aside from this one, we also have the interscorer reliability. So the interscorer reliability is the degree of agreement or consistency between two or more scorers or judges or raters with regards to a particular measure. So this is the type of reliability that we use when coding a non-verbal behavior. And for some, they say that this is a good way to address the possible biases in scoring. So, paano ba siya ginagawa? So, if you would, or kung nanonood kayo ng Olympics, so let's say for example, yung diving o kaya gymnastics, floor routine, di ba? May makikita kayong mga score after their floor routine, after they have dove, may makikita kayong mga scores na ipa-flash sa electronic board. So those are pag kinompute nyo yun, yung tatlong scores na yun, tas mataas yung reliability niya, ibig sabihin that in terms of accuracy of scoring, accurate yung mga judges na yun. However, if the scoring is like this, ito yung sinasabi ng tatay ko pag nanonood siya ng boxing ni Pacquiao, sabi niya, ay, madaya yan si gantong judge, binayaran. It happens when the scoring is somehow like this. Kumari si Judge 1, iniskoran nagbigay siya ng score na 8.9. So 8.9, si Judge 2 nagbigay siya ng score na 9. And then biglang si Judge 3 nagbigay siya ng score na 6. So yung 8.9 at saka 9, tas biglang 6, biglang baba. So pag kinompute mo yung reliability nun, medyo mababa siya. So, ibig sabihin, in terms of accuracy of the raters, hindi ganun ka-accurate. So, dito na natin nakikita yung mga sinasabi ng parents natin na, yan, pag nanonood sila ng mga sporting events, tas may ganung scoring, sabi na, ay, andaya, luto, yung mga ganon. So, they have an idea already of inter-scorer reliability. Kasi, from the get-go, kapag tatlo, kayang-kaya mo siyang makita kung magiging mataas ba yung reliability niya or hindi. Okay. So, we call this the coefficient of inter-scorer reliability. Ayan. And we use this to determine the degree of consistency among scorers. Okay. So, this is the pie chart that we have in terms of the hypothetical, the sources of variance in a hypothetical test. So, ayan. Again, ang purpose natin is to get a larger part of the pie for the true variance and limit the error that we have here. Diba? Katulad dito. 18% due to test construction, 5% sa administration error, 5% sa unidentified error, 5% sa scorer error. But the bigger part of the pie is still for the true variance. Kasi nga, again, our purpose is to get the test taker's score nearer to the true variance. And minimize the error variance. Kaya sabi ko sa inyo, 'di ba? Pag like for example do sa test, although kung ginagawa niyo naman 'yun and that's good, you call out, sabi niyo, "Ma'am, wala pong ganito. Ma'am, yung sagot po sa gantong number ay parang wala pong sagot." Or, "Ma'am, umulit po yung letter yung mga choices, umulit po yung letter A and letter C," yung mga ganon. So, that's part of error due to test construction. Tapos yun nga, di ba yung kaninang sabi ko, pag yung test administrator nyo, yung maingay, siya pa yung daldal ng daldal habang nagtetest kayo. So, that's an administration error on the part of the test administrator. So, kaya nga, i-call out nyo yun. Kahit ako, pag maingay ako, i-call out nyo ako. Kasi nga, again, we're trying to minimize this part and maximize this part. In any type of test yan. Okay. So, okay, ayan. So, related to reliability estimate, ayan, the nature of the test is closely related to the purpose and use of reliability coefficient. So, in your case, the reliability coefficient that we're going to be using is in their item consistency. Kasi nga, we're trying to establish a test that's reliable in the sense na ang minimeasure niya talaga or the scores that it will reflect will indeed be reflective of the construct that you have came up with on the project, diba? So, ano-ano ba yung mga dapat nyong i-consider in this sense? So, unang-una dyan is, ayan, are all test items homogeneous or heterogeneous in nature? So, bakit? Kasi nga, again, when we're dealing with a homogeneous trait, we're just measuring one particular trait. Pag heterogeneous na yan, so a good example of that would be neopy. So it's still personality traits but different personality traits. And it's a bit difficult. Ayan, dito ang magkakaroon ng mga reliability estimate na hindi lang test, retest, or inter-item. Kasi nga, how can you make an inter-item kung iba-ibang trait, particular trait ang minimeasure mo? And you're not even sure kung how related is trait 1 to trait 2. Okay. As well as, ayan, kung dynamic ba or static yung trait na minimeasure mo. Bakit? Kasi nga, pag dynamic siya, it tends to fluctuate or vary, or let's say in terms of movement, marami siyang movement, di ba? And for it to be static, of course, in terms of stability, mas stable siya. Also, the range of test scores is or is it not restricted. So, ayan, kailangan nyo pa rin yan i-consider. Also, if the test is a speed or power test, so like for example, yung mga quizzes natin. So, yung mga tanong actually sa quiz B, it's a speed test but also a power test. So, pero kasi more of a speed test siya lalabas. Kasi pabilisan ng pagsagot. But you still have to get a large number of correct answers. With the power test naman, ito yung nangyayari sa inyo pag quizzes natin, post-test, because we're after how many correct items that you have answered. Also, if the test is or is not criterion reference, kasi mag-iiba na naman yun. Kasi nga, the reliability estimates will have to depend on that factor. Okay, so aside from these factors, we're also going to be talking about true score model and alternatives. So, for the longest time, we have been developing tests based on the true score model, which is often referred to as the classical test theory or the CTT. So, this is the one that's used before. Kaya nga closely related ang education assessment at saka psychological assessment because the two have been using the same test theory before. Okay. Pero in part or sa part ng psychology, it had moved on from CTT. Kasi nga, CTT is too simple. Hindi na natin yan ginagamit masyado. Kasi nga, it's too simple. Tapos, hindi pa niya nadidetermine yung specific response na gusto natin depending on the construct that we want to test. Okay. However, syempre pag-uusapan pa rin natin siya dahil nga isa siya sa mga foundations ng mga test natin. Ayan. According to the classical test theory, ayan, meron tayong true score, which is a value that reflects the individual's ability or trait level as measured by a particular test. So, ito yung nakikita natin, again, sa quiz natin, sa mga achievement test natin. It's more based on the CTT. Okay. So, and bakit ba siya mas ginagamit? Mas ginagamit nga siya kasi nga the assumptions are easier to meet kesa sa item response theory. So, mamaya naman sa item response. Yan. Kaya naman din tayo nag-move on from CTT dahil ayan. A problematic assumption of CTT has to do with its assumption concerning the equivalence of items on a test. So, ayan. Hindi niya to ma-establish. Kasi nga, sa sobrang simple ng idea niya, in terms of equivalent ba tong item na to sa item na to. And mamimeasure ba nila yung parehong trait. Ayan. Hindi niya yan kayang masagot. Okay, so the other theory that we have is, of course, the domain sampling theory, wherein estimates the extent to which specific sources of variation under defined conditions are contributing to the test score. So, kung mapapansin nyo, meron kayo sa construct nyo na domain, right? So, yung domain na yon, it will help you to see if the trait is present in this particular situation or in this particular condition. And by doing so, mas mabilis kayong makakagawa ng mga items, and we're also testing the construct in various situations. So, ginagawa nyo siyang more diverse. Unlike pag hindi natin siya ginawa, or parang we just follow the classical test theory, na isang baksakan lang siya na all about aggression, but we didn't really specify particularly what type of aggression. Medyo malabo siya gawin, or medyo a bit tricky to establish, as well as to see the trait being exhibited in various situations. Okay, and then also we have the generalizability theory. This is the idea naman here is that the person's test scores vary from testing to testing because of the variables in the testing situation. So, ayan. Instead of conceiving of variability in a person's scores as errors, Cronbach encouraged test developers and researchers to describe details of a particular test situation or universe leading to a specific test score. So, and the universe is described in terms of its facets, including the number of items in the test, the amount of training the test scorers have had, and the purpose of the test administration. So, kung makikita nyo, yung gawa naman itong theory na to is also addressing yung mga error variances, particularly yung sa pagtetest, pag-score ng test. So, and paano siya ginagawa, ano ba yung training nila, para in terms of understanding the score itself, the error variances can be somehow minimized and if not completely avoided. Okay, wait lang. Okay, now this is now the how the tests being developed in the practice are gearing towards two. So we're using the IRT, or the item response theory. So the item response theory gives us a model, the probability that a person with X ability will be able to perform at a Y level. Okay, so take for example a person diagnosed with clinical anxiety. So that will be the X ability. So dahil nga diagnosed siya with clinical anxiety, so at that the level of that anxiety will be higher than the normal. Unlike if you are going to compare that person, a normal person who just have or who doesn't have clinical anxiety. So, pag kinompare mo yung level ng anxiety niya, or you use the same test on them, they would show a lower level of anxiety. So that's the best possible way, or the simple way to explain the item response theory. Kaya nga maganda siyang gamitin, especially if you have a special group or subgroup norms in your case doon sa development ng inyong test, kasi nga meron kang ganung idea, like for example, sige, dahil nga ang most na norms na gagawin nyo ay more on the difference between genders and ages, so age norms and gender norms lang. So let's say for example your literature and theories tell you na in terms of the trait of kindness, so mas so X ability yung kindness, diba, and Y ability yung level, Y ability Y is the level of the ability. So, if we're going to compare the kindness level ng female sa male, 'di ba? So, it will be higher than males. Kasi nga, let's say for example, your theory and literature says na yun yung result. So, ganun yung makikita nyo doon. So, kaya, dapat pagsasagot sila, may certain type silang sinasagot, yung grupo na yan, compared to the other group na ang sabi ng theory and literature nyo ay mas mababa yung level ng X ability niya. Okay, so I hope that you're getting what I'm saying. It's just a bit difficult to explain if I'm just doing the PowerPoint presentation. Anyway, so the IRT actually marami ang methods and techniques. So pag nag-laboratory tayo, so we will be discussing further yung mga specific approaches. But one thing about this one, IRT, and so IRT incorporates considerations of items level of difficulty and discrimination. So this is a good thing about IRT kasi nga, how does this group discriminate their answer from this particular group? So a good example to this one again would be the MMPI. So, MMPI has two normative group, the college students group and the clinical group. Doon nila in-establish yung clinical norms nila. So, they're able to establish the IRT using the item discrimination. Bakit? So, like for example, for the statements or items that measure clinical behavior, so let's say for example, psychopathic deviate, dapat ang sinasagot ng clinical group nila doon would be, of course, true, hindi false. And the college group will be answering that item as false. Kasi nga, ayun nga yung magdi-discriminate ng group na to the other group. So, ayan. So, ma'am, bakit hindi mo dinidiscuss yung difficulty? Difficulty kasi it's more of, hindi siya masyado applicable sa personality tests. Kasi nga, when we talk about item difficulty, ayan, it relates to an item not being easily accomplished, solved, or comprehended. It more applies to a test that has a keyed-in correct and incorrect answer, particularly yung mga achievement test natin, diba? Or IQ test. It also has, it's more an item difficulty rather than discrimination. So, whereas, ayan, discrimination refers to the degree to which an item differentiates among people with higher or lower levels of the trait, ability, or other variables being measured. So, katulad ng sinabi ko sa inyo kanina, if we are comparing the clinical group versus the normal group on a specific clinical trait, then the clinical group should answer true or should score higher than the normal group. Okay, so aside from these theories, we're also going to be kailangan din natin isama ang standard error of measurement sa usapan ng reliability. Okay, so SEM, so iba pa to sa SME nyo ha. Ang SME natin ay subject matter expert. Ito naman, SEM. Ang SEM ay standard error of measurement. So the standard error of measurement is the precision of an observed test score or an estimate of the amount of error inherent in the observed score or measurement. Okay. So the higher the reliability of the test, the lower the standard error. So, the standard error can be used to estimate the extent to which an observed score deviates to the true score. So, like for example, pag tinanong ka, anong reliability ng test na to? So, sasabihin mo, 90% yung reliable. So, your standard error would be 9 to 10%. 9, kasi baka mamaya 9 point something kineme yung ano nyo, yung measurement nyo. So, parang ano lang din yan, yung sa, yung dati pa natin pinag-uusapan. Ano ba yung example ko nun? Yung sa safeguard, di ba? Gano'n ka-reliable yung safeguard sa pag-aalis ng bacteria or ng dumi sa kamay ko pag naghugas ako ng kamay gamit yung sabon na yan. Diba? Sabi nila, 99.9%. Ang kanilang standard error of measurement in that particular percentage is 0.01. They're that confident in their product, right? So, this can also give us an idea how reliable is the test based on the SEM. Pag nagbasa kayo ng manual, mas more na di-discuss ang SEM. Hindi nyo makikita na, this is 90% reliable sa isang test manual. Ito yung mas dinidiscuss. Okay. Then moving on to the standard error of difference. So this is a statistical measure that aids the test user in determining how large a difference in test scores should be before it is considered as statistically significant. So yon. Okay. So this is more pag nagpa-practice na kayo. Bakit? Kasi nga again, when you're doing the practice already, titingnan nyo gaano ba kalaki yung gap nitong test na to sa isang test na to, measuring the same thing or similar thing, right? So, by doing so or by establishing this, you're able to arrive to a more accurate decision making or a better recommendation for your client later on. So, ayan. In establishing this, we can use or we can consider these questions. So, una-una, how did this individual's performance on test 1 compare with his or her performance on test 2? Pangalawa, how did this individual's performance on test 1 compare with someone else's performance on test 1? Diba? So, ito, comparing to himself or herself. Ito, comparing the same test to another person. This one, comparing the person's test 1 to his test 2. And then, pangalawa, comparing the person's test 1 to another person's test 1. Okay. On the other hand, ito naman pangatlong question, how did the individual's performance on test 1 compare with someone else's performance on test 2? So, magkaibang tao, magkaibang test din, yung pangatlong tanong. Okay. So, that's the end of the discussion for reliability. So, please post your questions doon sa comment box para makita ko ano yun din yung hindi yung maintindihan or yung medyo hindi malinaw kasi pagdating na ng application tas hindi nyo naintindihan yung mga reliability estimates as well as yung mga theories related sa reliability, mahihirapan kayong i-run yung mga statistics kahit na may application tayo sa laboratory natin. Okay? So, that's all for today.